Definitely. Mhm. Can you hear me? Please use the chat to answer me. Hello, can you hear me? No, no, hear me? No, Can anyone, sir, you can hear me, Amma? Hello, can you hear me now? Can you hear me? Hello, can you hear me now? Can you use the chat box to answer this? Someone to solve this. Whenever everyone see the screen, it's use the check to answer. Okay? If you have any problem, you can check me. Okay. There's not the okay. Good afternoon, everyone. Also, good. Can you hear me now? So let me start the course. Good afternoon, everyone. Our course is NPM 3212 numerical analysis. So this is a two credit course. Okay, so we will have like what we have done in earlier courses. If it is two credits, okay, we have to have four questions in the semester exams. So according to that, I have divided the course into four chapters. So you can see that one. So first of all, this course is named as numerical analysis one. Okay, so there is one another part also there. So it will come later semesters. Okay. So let's see the aim of the course to solve algebraic and transcendental equations. And of course, the next one is to calculate derivative integrals and to perform error analysis and various numerical methods. So we can pick what these things in when we are studying this. So next part, let's see the intended learning outcomes. There are five outcomes should be accomplished during this course to represent the numbers use text, computer arithmetic, as well as to solve an algebraic and differential equation. Next one also linear differential equation. Also functions using appropriate numerical method. Fifth one, differential equation. So we can see one by one. By this course content, I have divided this course content into four chapters for listeners. So each chapter carry one question in the semester exams. So first chapter is about a number system and errors, and also solution of the equation one variable. Next sections, we can see the second, third, fourth, in the also, this is very important thing to remember. These are references. You can get the books from the library. So I have sent the notes so you can find it. Okay, so first chapter is number system and errors. So there are two sections. Okay, so one by one we can finish up to get finish up the chapter number one. First one is a number system and errors. So let's see this first class to start with the section number one and the chapter one is the number system and errors. So okay, number systems and errors. So what do you think? The number systems. So you already heard all these things from the school level. So we can. Have I got my voice not clear? Is that okay now? We'll continue. The number system and errors. So first of all, let's see what is number system. So numbers we know from our nurseries and the school levels we have studied all about what is the number systems. So from that we're gonna see some that what it is really is about in this course. So the number system is defined as a system of writing for expression numbers. So to express the numbers, we use this system of this number systems to write it. Okay. Still, my voice is not clear. Hello, can you hear me then? Okay, likewise, numbers can be divided into mainly in our earlier knowledges, we have divided into real and imaginary. Okay, the real number can be divided more into rationals. The real numbers can be divided into rational as well as this will be irrational. So irrationals can be I think we may remember that's square root of 2 or 5, like that's numbers we called as irrationals. Also, it would be you can divide it more. This one rational can be written as integers and also fraction. Okay, still it's going on. So from this real the number system. So mostly we call this one as a complex number. Okay, this is our main priority to study this. Okay, let me continue our knowledge. So the number system is defined as a system of writing for expressing number. For example, 123. It is one of the number. Or for example, 2.589. So that is also one kind of representing the numbers. So that's what this is. Is that not clear? Now, can you hear me well? Is that now okay? Hello, can you hear me now? Sorry about the technical problem. Hello? Okay, I will continue. Okay. So the number system is defined as a system of writing or expressing number. Then it is the mathematical notation for representing numbers of a given set by using digital or other symbols in a consistent manner. So this is the definitions for the number systems. So in I think I have a little bit changes in my notes and the module I have uploaded. Okay, so when it is something different, you just write down and correct it in video. So I just checked and added some examples in my note, but I didn't put in your notes. So please note it down everything. Okay. Next one, it provides a unique representation of every number and represents the arithmetic and algebraic structure of the figures. So it provides a unique representation. If it is number, it provides a unique representation of every number and presents the arithmetic and algebraic structure of the figures as well. So here figures we hold as also as the digits. Okay. So it also allows us to operate arithmetic operation like addition, subtraction, and division. So you may know using the numbers we can using the numbers only, we can do some arithmetic. For example, if I have 125, it's one of the number representation. Likewise, 2.583, which is also one of the number representation. So you can write this one as 283 times 10 to the power 1. 10 to the power -3. Right? This is also one of the number systems. So these are kind of number systems. Using these number systems, we can add, for example, 253, one of the number systems, 2.58. So if you have, you can do some calculation. You can add, you can subtract, you can multiply, you can divide, you can divide like this. So these are okay. These are the usage of this number system. Let me continue the notes. Okay. Now here it also allow us to operate arithmetic operations. Okay. Like addition, subtraction, and division. So in this section, what we are actually doing is from our earlier knowledge, several mistakes relating to the computer representation and arithmetic of numbers will be discussed today. So we're going to study how we can represent the number system as well as the errors. Okay. So what are the errors coming when we are doing some computer representations, all these things we're going to study in these sections. Okay. And okay, now let me go to the next section. It is called as a representation of numbers. So how it is already known thing. Anyway, let's see how we can represent numbers. So let's say an integer n, capital N, consists of an optional sign. plus and minus. For example, we also have negative numbers also. We need to indicate plus 123 minus 256 is a different numbers. Plus means it's a positive. Sometimes we put the plus or we don't need to. So that's how we follow the rule. But if it is a negative, we should have to put the negative numbers before the number. So followed by a string of decimal digits. So what do you think? Decimal digits means the actually these are the decimal digits 0, 1, 2 up to 9. We call as a decimal digits. So there are some different way of representing this. Also, there are binary system, octal systems. This you may find in the computer studies. So if it is a binary means 0, 1. So octal digits means 0, 1, 2 up to 7. But decimal numbers means tens numbers. So it has 0, 1, 2 up to 9. Okay. So it is followed by a plus sign here. So it can be represented in this way. So this is a way we can represent the numbers. That is plus or minus any number, any symbols to become. Mostly for the plus we don't put, but here for the representation we are using. Okay. So what do you think? D1, D2, D3 up to Dn. These all are the decimal numbers, maybe 0, 1, 2 up to any number of between these numbers. And also, so it says D1 not equal to 0. So it's okay. If the meeting finish, please join again. Okay, it says only 40 minutes. So if it is finished, everyone can use the same link to join the meeting again. Okay, so D1 not equal to 0. So what do you think? If D1 equal to 0, we don't need to consider that. For example, if we have 0, 1, 2, 3, we will say like this. So this 0 doesn't consist anything. So we have to have. So it is possible to write like this way. So this 0 doing nothing. So or else 0, 0, 0, 1, 2, 3 means these zeros doesn't have any meanings. So better we write just only 1, 2, 3. So if you are writing the number system, n is equal to plus or minus d1, d2 up to any number of dn. Maybe this may be any number of digits. Okay, 1, 2, 5, 6, 7, any number of million, billions. Okay, but they say this d1 always not equal to 0 to represent the ones. Okay. Let's continue the module. Okay, also this I can be 1 to up to n. M can be any number of values, maybe up to 4, up to 5, like that. Okay. Next one, let's see one more. In the decimal number system with base 10. Okay. So in this base 10, this representation you may know. So what is the value of the numbers? For example, say d1 times 10 to the power m minus 1. So n number of values. So this is indicating m minus 1 value. This will be m minus 2 value, m minus 2 up to m minus n. So let me name it here. This one. Now, for example, n is equal to plus or minus d1, okay, 123. So n is equal to 123 plus or minus. So what is the unit values of this one? So this is we in our school level we say this will be 0. This will be 10 to the power 1. This will be 10 to 1. This is a unit value. This is a 10 12. This is 100 12. So likewise, they say plus 1 times 10 to the how many m is what? 1, 2, 3. So m will be 3. So we have to have here m minus 1. So 3 minus 1 plus again 2 times 10 to the power 3 minus 2 plus again 3 times 10 to the power 3 minus 3. So you know this one plus 1 time 10 3 minus 1 will be 10 2 plus 2 times 10 3 minus 2 will be 10 to the power 1 plus we know always any 0 value will be 1 or any number of 1000 or any number of 0 will be 1. So this one we're going to use here. So this will be 3.1. So this will be plus 1 time this 10 to the power 2 will be 100. 100 plus 2 to the power 10. So 20 plus 3. This is how this number has been created to the 1, 1, 2, 3. Okay, this is what they are talking about. So you understand that number system representation. So let me continue on with you. Okay, this is what they say. So n is equal to, if you are, I mean, from this one, so the number system, so number system plus or minus d1, d2, d3 up to dn can be written in the decimal base 10 format is ba1 10 to the power n minus 1 plus b2 10 to the power n minus 2 up to n minus 1 n minus 1 0. So you can see this example. Can you try this example in yourself? See whether you can do this thing. This is school level 1, so you're going to do 1, 5, so this is simple one. So 1 time 10 to the power, there are 4 numbers. So m is equal to 4, 4 minus 1, 4 minus 2, 4 minus 3, and 0. So this is the base 10 representation. So let's go to the next section. Next section is numbers, but it is talking about the real numbers. Okay, so the real number has 2 standard forms. So one is fixed point form. Okay, so fixed point form is the fixed point form consists of an ordinal sign plus or minus and also available, followed by 2 unsigned integers separated by a decimal point. I will explain what it is. Okay, so this, for example, x is a value, it's equal to maybe plus d1, d2, d3 up to dj. See this carefully, there is a dot there. It is a decimal point. And dj plus 1, j plus 2, j plus j up to dm. Okay, in this part, these d1, d2, dj up to dj we call as a integer part. And after the decimal point, we call as a fractional part. This already you know. So this is the representation of the fixed point form. For example, So for example, 2,173 points, 213. Okay, so we have